All right, good morning. I'm going to go back here a page. Today we're going to do our second day of section 911. And we're looking for what is the multiplier. Basically, what is the relationship between circumference, diameter, and what's this pi thing? So they're giving you a hint there as we go. Hopefully you did your homework. We'll be checking that. You did that yesterday. If you want to look around at the homework, I'm going to go ahead and scan through these. You can pause as you need to look at your answers. That was 9:10 and 9:12. A little bit more of 9:11. And then here was 9:14. Proportion problem. I used the giant 1 to figure it out. And then 9:15. Okay, so let me reset that. Yesterday, or last time we met, we took some data where we had to measure the circumference around a bubble. So we blew a bubble, we popped the bubble on a piece of paper, and then we put a string around that bubble, that circle, and measured the distance around the circle. And then we took the same, we took a measuring tool and we measured the diameter, the distance across the circle through the center of the circle. And this was our data. And then we graphed that data, and interestingly, it made a very straight line. If you were to draw the line of best fit through those dots, it's pretty darn straight. So there must be some mathematical relationship between the circumference and the diameter. If you were to look at the diameter numbers compared to the circumference numbers, about how many times bigger is the circumference than the diameter in every case? Let's see, this is about 9, that's about 27. 5 and 15, 7 and 22. About how many times? 10.1 becomes 31.7. This one's a little harder to see because it's big numbers, but 18.4 becomes 57. About how many times? So you can also see it right here. Every time you gain 3 in circumference, it takes 1 inch in diameter. A little bit more than 3 if you look really carefully. It's above that line. Similarly here at 2 centimeters diameter, it's a little bit above 6. At 3, it's a little bit above 9. It is above it though, and it's actually getting bigger. You notice that the distance above the line is increasing. So that means it's probably more than 3, but only a little more than 3 times bigger. So let's go over here, 9-3. What does my graph show? Discuss the following questions with your team and be prepared to explain your ideas. So I want you taking notes on this into your notebook. A, how can you use your graph to show the circumference and diameter are related proportionally? All right, well, to be a proportion, 2 things had to happen. Number 1, the graph had to go through the origin. Should 0 centimeter diameter have a 0 centimeter circumference? Should. And number 2, it had to be a straight line growth. That's pretty straight. So I would say this is definitely proportional, and maybe my reason then would be, let's see what we got here. Turn that on. All right, so I could say something like our graph goes through the origin and has a line of best fit. This is proportional. Now, problem B, approximately what is the multiplier between the diameter and the circumference? So we could say the circumference is approximately 3 times the diameter. Approximately. Now, for thousands of years, people have been trying to figure out what that is more exactly. 3 times is good, but they had to do better to be more accurate with their architecture and design and science. So let's use this approximation to figure out the answer to 9.4. If the diameter of a bubble were 9 centimeters, predict its approximate circumference without measuring it. Justify your answer in as many ways as you can. So if the diameter of the bubble is 9 centimeters, and we know that the circumference is approximately 3 times the diameter, then we could say the circumference is approximately 3 times 9. So the circumference is approximately 27 centimeters. Because it's going to take about 3 of these diameters to wrap around the outside. It's actually going to take a little bit more than 3, because we know, if you look back at our graph, that again, this, for every 1 centimeter, you're going to be a little bit more than 3. If you look closely at that, it's a little bit more than 3, because it crosses just above the grid line. This at 2 is a little bit more than 6. So it's not quite 3, it's a little bit more than 3. So this is a good enough approximation for this moment, but we got to do better. So 9.5, the ratio of circumference to diameter for circles has been measured with increasing accuracy since 1650 BC. The ratio has been found to be equal to pi. In English, pi is spelled P-I and is pronounced pi. It's actually a Greek letter. So this is the Greek letter pi. It is an irrational number, which means that there's no way to write it as a fraction with integers. The value of pi is slightly greater than 3. Find the button marked pi on your calculator. So every scientific calculator is going to have a pi button. Some little calculators will have it. My pi button is right here. If I click on that pi button, it gives me this really long number. 3.14159265389793223846264338327955, and it's going to keep going forever. It never repeats and it never stops. Pi is called an irrational number because it never repeats and never stops. And irrational, see the word ratio hiding inside of that, means that it's not a ratio. You cannot write it as a fraction. There's no way to write it as a fraction and be exact. You can approximate it with a fraction, but not be exact. So part A, write down the decimal equivalent of pi accurate to the nearest hundredth. So let's see here, bring up my calculator. 3.14159. The hundredths place is right here at the 4. So the thousandths place will tell us how to round it. Since that's a 1, the 4 is going to stay a 4. It will not round up. It'll stay a 4. So this is 3.14. So pi is approximately 3.14. There's no way to write it exactly because the decimal goes forever, but we can approximate it to the nearest hundredth. The fraction 22/7 is often used to approximate pi. What is the decimal equivalent of 22/7 accurate to the nearest hundredth? So 22 divided by 7 is going to equal, since we already have our calculator, 22 divided by 7 equals 3.142 to the nearest hundredth. The 2 will make that say about 3.14 again. So this is approximately 3.14. Notice that there is a difference between this number, 3.1428, and the actual pi value when you click the pi button. This is 3.141. So 22/7 is not pi, but it's close to pi. Sometimes, if you need a rough approximation, you can use this fraction in a pinch. Problem 9.6. Work with your team to generalize the relationship between circumference and diameter of a circle. In other words, describe how you could calculate the circumference of any circle if you knew the diameter, and how you could find the length of the diameter if you knew the circumference. So I'm going to do 9.6 right here. So if we know the diameter, so if we know, well, let's start it off this way first. Hold on, I'm going to change that. All right, so here's what we know. If you take the circumference and you divide it by the diameter, you get pi. So if I want to solve this and see what circumference equals, I could do a little bit of math. So circumference divided by diameter is pi. If I multiply this by d, remember my fraction busting? So my common denominator is d. That would make a giant 1 here. So c would equal pi times diameter. That's one way. So if you know the circumference is about 3 times the diameter. Well, that, to be more specific, it's not just about 3 times, it's exactly pi times the diameter. I prefer to write this as c equals d pi. Most books will actually do pi d, but I have a reason which I'll reveal later why I prefer this. Then they said, so if you know the diameter, you can calculate the circumference. If you know the circumference and you want to find the diameter, so let's see. If I now know that c equals d pi, and I want to calculate the diameter, and I could divide this by pi and divide this by pi, so that the diameter is the circumference divided by pi. Because see how this is a giant 1? Diameter equals circumference divided by pi. So there you go. Now, the only equation of these two that I want you to memorize is this one. C equals d pi. The distance around a circle, the circumference versus the diameter. If you take the diameter times this number pi, the button on your calculator, then you will get the distance around a circle. Let's see here. If I look back at my graph, let's see if that holds true. So if I want to go from 0, 0, all the way to this nice point way up here at 10, was it 10.1 comma 31.7. I got that from this part of the table. If I want to go from 0 to here, that means that it took 10.1 centimeters to go to rise a total of 31.7. 10.1 centimeters. So my rate in this case is going to be 31.7 divided by 10.1. And I want to see how close we got to pi with that. So if I take 31.7 divided by 10.1, I'm going to get 3.138. That's really close, 3.14 if you round that. So we actually got really close with this bubble to the actual value of pi. This is 3.14. I'm pretty impressed. So anyway, getting back to the problem, that was a little side there. So if you know the diameter, you can calculate the circumference. Problem 9.7, remember the tennis ball problem where we took a piece of string and we wrapped it around the tennis ball can, and then we compared that string to how tall the tennis ball can is. I don't know how long that string's going to be, but we're going to find out. Discuss it with your team again. Has your prediction changed? Why or why not? So you got to look back at your prediction for 9.1. Work with your team to test your prediction. So there were only 3 options. Either the string is shorter than the can, equal to the can, or taller than the can. So now that we know that the circumference is the diameter times pi, I suppose we could measure a tennis ball, or we can just estimate it. Let's say we have a tennis ball that has a diameter of, I don't know, 2.5 inches. So if the circumference is 2.5 times pi, then we could approximate that by using our calculator. We could take a calculator here and we could say, whoop, not that, that's not the calculator, there's the calculator. So now we could say 2.5 times the pi button equals, and we get about 7.85 inches. So the distance, 7.85 inches around. The distance around this, if the diameter was 2.5, the distance around that would equal 7.85 inches, about. So if we take that string and we raise that string up this way, how would it compare? Well, I think the string is going to be taller by a little bit, because if you take the 3 tennis balls and assume that the top has really no thickness and the bottom has no thickness, from this tennis ball to here, that's 2.5, that's 2.5, that's 2.5. That would only be 7.5 inches versus 7.85 inches. It would be really close. It might be about 1/3 of an inch higher, right? About 0.35, so that's about 1/3 of an inch higher. It's going to be a little bit higher than that can. But it's really close, right? So if you said they were about equal, yeah, okay. I think it's a little bit higher though. It's not lower, but it's definitely going to be close. Actually, I'm going to make that a little bit better. So the string is 7.85 inches. Wow, that's messy. And the can is I would say 7.5 inches. So the string is slightly longer. That is my therefore statement. Okay, Problem 9.9, I want you to write a learning log. The title is Circumference and Diameter, and the learning log should tell me what you learn about circumference and its relationship to diameter. So write down something. Title it Circumference and Diameter. Put down today's date if you want. And then maybe draw a picture of a circle and maybe have the diameter through the center. And then maybe write the word circumference as if it's going around the outside. A good visual. And then I want you to write the formula, circumference equals diameter pi. And then over to the side, pi is approximately 3.14. Maybe a little arrow that points at this that says irrational. So for most of the math, I want you to use 3.14. If I ever say to use 22/7, you have to use 22/7. But most of the time, it's either this number or the button on your calculator. If I don't tell you, use the button on your calculator, okay? And then let's go on to number 8. We're going back one now. Scientists have measured the diameter of the Earth at the equator to be 7,926 miles. So right here at the equator, that's the great circle, the one that goes around the middle of the Earth, that is 7,926 miles approximately. If you were to travel all the way around the Earth along the equator, approximately how many miles would you have traveled? So if you were to go all the way around the equator, oh, I'm sorry, I have it drawn wrong. Horrible, bad, Mr. Punches. Okay, let me reset this here. Hold on. Okay, so the diameter of the Earth, diameter, there we go. So that means from here all the way across the Earth, that's 7,926 miles if we go right through the center of the Earth, the core. So if you were to travel all the way around the Earth to the equator, approximately how many miles would you have? What they're asking us to do is they're asking us to calculate the circumference if we know the diameter. So the circumference is going to be equal to 7,926 multiplied by pi. The circumference is approximately 7,926 times pi equals 24,900. Let's just round it to there. 24,900 miles. That's pretty far around. All the way around, 24,900 miles. Since the Earth rotates in 24 hours, that means the Earth must be rotating a little bit more than, pardon me, more than 1,000 miles per hour in a circle. Because 24,000 miles is all the way around, a little bit more, 25,000. Interesting. So, part B, if it takes the average human 2 hours to walk 5 miles, how long would it take to walk around the Earth, assuming it were actually possible? So, if you can go 5 miles in 2 hours, I'm going to use a proportion. How long would it take to go 24,900 miles? I want to figure out what x is. So I could figure out how many times I got to multiply 5 to get this number, or I could cross multiply. I think I'm going to do that. Let's cross multiply. So we are going to get 5x is equal to 49,800. Is that right? Let me double check my math here. 24,900 times 2. Yes. And then we're going to take this number and we're going to divide it by 5 so that we can get our giant 1x, or 1x here. So x is going to equal, let's see, divide by 5 equals 9,960 hours. Eesh. A walk around the earth. So wait a second, how many days would that take if you were to go 24 hours a day? Divided by 24 hours. 400, it would take more than a year. Oh my gosh. If you could even do it. Okay, back to this. Additional challenge number 2. Signals that travel across the internet are often carried through fiber optic cables and travel at the speed of light, 186,000 miles every second. At this rate, how long would it take an email to travel around the earth? So let's see. If you have 186,000 miles for 1 second, how would that compare to 24,900 miles? See how I'm using a proportion again? And how many seconds would that be? So I'll call this y for right now. I already used x. So I think I'm going to cross multiply again. So if I cross multiply, I get 186,000 y equals 24,900. When I divide by 186,000, I get my giant 1. Y is going to equal, oh, this is going to be good, 24,900 divided by 186,000 miles per second. It's going to take 0.13 seconds. 0.13 seconds. It takes 13 hundredths of a second for a signal to get all the way around the world. So you could text yourself, send it around the world, and it would be back in 13 hundredths of a second. Crazy. All right. Your job is 9:16 to 9:21. Thank you for participating. Thank you for taking notes. Thank you for listening and being a good audience. Have a good day.